Most of the time, when we try to factor a polynomial of a higher degree, a zero is not given to us. In this video, we are going to explore that option and the things that we will have to do to successfully factor a higher degree polynomial. So if zero is not given to us, we can find some possible zeros, then test them using the remainder theorem. To find possible rational zeros, we are going to take the factors of the constant term and divide by the factors of the leading coefficients. Let's look at example 7. Given f of x is equal to 2x to the fourth plus 5x cubed minus 2x squared minus 11x minus 6. Part A, we want to find all possible rational zeros. The keyword here is possible zeros. It doesn't guarantee that we are going to find all the zeros, but if we can just find one zero, then that will really help us find the rest of the zeros. So to do part A, we are going to first determine the constant term. The constant term in this case is negative 6. So we want to find factors of negative 6. The leading coefficient is the coefficient in the leading term, which in this case is 2. So we want to divide that by factors of 2. Factors of 6 could be 1, 2, 3, 4 doesn't go into 6, 5 doesn't go into 6, but 6 does. And don't forget the plus or minus scenario for each of them. Factors of 2 are, again, plus or minus 1, plus or minus 2. Now let's simplify each of these combinations. So we're going to combine like this, 1 over 1, then 2 over 1, 3 over 1, 6 over 1, and then we have 1 over 2, 2 over 2, and so on. Anything that is repeated, we don't have to include it. So 1 plus or minus 1 over plus or minus 1, that will give us plus or minus 1. Plus or minus 2 over plus or minus 1 will give us plus or minus 2. Plus or minus 3 over 1, that will give us plus or minus 3. And then same with 6, it's going to be plus or minus 6. Then we'll also have 1 over 2, so that's plus or minus 1/2. 2 over 2, that's already 1. 2 over 2 is 1, which we already have, so we don't have to include it again. But then we have 3 over 2, so we have to include plus or minus 3 over 2. And then 6 over 2, which is 3, but we already have plus or minus 3. So those are all the possibilities. Next, we're going to factor. To be able to factor, we need to figure out which of these numbers are going to be a zero of the polynomial. Now, we do not need to test every single number here on this list. If we could test one and find it, then we will go from there. 1 and negative 1 are very common numbers to test. Let's test 1 first. 1 being a 0, we are going to use synthetic division because that is the fastest way. List all the coefficients. We have 2, 5, negative 2, negative 11, negative 6. The 0 is 1. Bring down 2. 2 times 1 is 2. 5 plus 2 is 7. 7 times 1 is 7. Negative 2 plus 7 is 5. 5 times 1 is 5. Negative 11 plus 5 is negative 6. Negative 6 times 1 is negative 6. Unfortunately, negative 6 plus negative 6 give us negative 12. We did not get the remainder to be 0. Therefore, 1 cannot be a 0 of f of x. Let's test negative 1 this time. Again, list all the coefficients. bring down 2. 2 times negative 1. 5 plus negative 2. 3 times negative 1. Negative 2 plus negative 3, that's negative 5. Negative 5 times negative 1, that's 5. Negative 11 plus 5 is negative 6. Negative 6 times negative 1 is positive 6. Now this time negative 6 plus positive 6 gives us 0, which is great. Now that the remainder is 0, we can conclude that x minus a negative 1, or x plus 1, is going to be one of the factors. So far, when we factor 2x to the fourth plus 5x cubed minus 2x squared minus 11x minus 6, we will get x plus 1. And not only that, we will also get this quotient. So the degree of the polynomial is 4. This one will be 1 degree less. So 2x cubed plus 3x squared minus 5x minus 6. And we are going to put it right here. So right now, this polynomial could be factored again. We can't simply use the AC method. That should only be for the quadratic function. So we want to be able to somehow narrow it down to just a quadratic function, and then we'll use the AC method. So we're going to repeat the process of finding all the possible rational zeros for this function right here, so we can factor it further. So to find the possible rational zeros of that highlighted functions, we'll take factors of the constant term, which is negative 6, divide by factors of the leading coefficient, which is 2. Looks like we're going to end up with the same list as before, and that's going to be plus or minus 1, plus or minus 2, plus or minus 3, 6, 1/2, and 3/2. So we're going to test again, and 1 and negative 1 are very popular numbers to be tested. So let's test negative 1 again to see if it's a 0 again. And if it is, then we have a 0 of multiplicity 2 because it happens twice. So we're going to test 0, the 0 being negative 1. List out all the coefficients from that yellow highlighted function. Bring down 2. 2 times negative 1 is negative 2. 3 plus negative 2 is 1. 1 times negative 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 6 times negative 1 is positive 6. And then add these two together, we get 0. So it looks like negative 1 is a 0 again. So again, factoring f of x. So far, we have x plus 1. And then that yellow highlighted function can be factored again as x plus 1, since the 0 is negative 1. So x minus a negative 1 is x plus 1. Furthermore, we're going to get another quotient here, which is this one has to be 1 degree less than the highlighted function that has degree 3. So this would be 2 plus 1x minus 6. So I can put in here 2x squared plus x minus 6. Now that we get it down to a quadratic function, we can factor this guy using the AC method. So let's factor on this side. We want two numbers such that when you multiply them, you get a times c, which is 2 times negative 6, that's negative 12. And sum is equal to b, which in this case, that coefficient b is 1. So the two numbers should be 4 and negative 3. 4 times negative 3 is negative 12, and 4 plus negative 3 is 1. So now we are going to rewrite the middle coefficient 1 as 4x minus 3x, and then bring down the minus 6. Factor by grouping, we have 2x times x plus 2. Bring down the minus sign. Factor out 3, we get x plus 2 again. Factor again, we get x plus 2 times 2x minus 3. So in the end, the function f of x can be factored as x plus 1 squared, since that appears twice, and then x plus 2 times 2x minus 3. Now we're ready to do part C. Part C, we need to find the zeros and their multiplicity. Now that the function is all factored, we can find the zeros easily by letting each factor equal 0. So we have x plus 1 equals 0. That means x is equal to negative 1. This one we have multiplicity of 2 because it has the exponent 2. X plus 2 is equal to 0, so x is equal to negative 2. This one we have multiplicity of 1. And then finally, 2x minus 3 is equal to 0. So that means 2x is equal to 3, or x is equal to 3/2. This one also has multiplicity equals 1 because the exponents here are both 1.